So artifact evaluation started about 10 years ago. And so in putting this together, I dug up this article that was published in the Communications from the ACM in 2015. And it was published by two of the originators of the current practice of artifact evaluation. And here's a quote. And our goal is to get to the point where any published idea that has been evaluated, measured, or benchmarked is accompanied by the artifact that embodies it. Just as formal results are increasingly expected to come with mechanized proofs, empirical results should come with code, right? And the question is, well, why? Why did we get to this point, right? So this was response to several things that were going on at the time related to sort of the replication crisis more broadly in science, but in particular, in computer science, while perhaps computer science hasn't had the same sort of replication scandals that other disciplines have had. There was a lot of feeling that we should do better, that we can do better and we should do better, right? And so why is it that we wanted to do artifact evaluation in the first place? So this is one of my favorite papers. So this was a paper from a conference called ASPLOS. It's a systems conference. This was from ASPLOS 2009, and one of the great quotes from this particular paper, it says, this paper presents a surprising result. Changing a seemingly innocuous aspect of an experimental setup can cause the experiment, to basically you can draw wildly wrong conclusions about an experiment, right? And so this gets into this problem about replication. So this paper poses a relatively simple question. Okay, the idea is, they said, well, we're going to look at GCC, right, and say, is O3 optimization actually better than O2 optimization? Okay, and so they use GCC to compile this and over various sorts of things, and you say, well, okay, you can see how it might that you can draw certain kinds of. You say, well, in a particular configuration in my setup, when I run this experiment, O3 is consistently better than O2 over a wide range of benchmarks. And then they changed it a little bit. They changed a little bit of, some little bit of this setup. In particular, they changed the size of the process environment, right? So the process environment, it's the environment variables that you get on Linux or something like that, right? And they said, if we vary the size of the environment, the number of strings and the lengths of those strings, right, that ultimately that information gets pushed on the stack, and so it causes the stack alignment to be a little bit different. And it turns out that affects the performance of this benchmark, right? You can get different results based on the size of the environment. Okay. You can also get different results based on link order. So as you know, you compile a program from lots of individual object files, you link them together, and they are in some order on the command line, and in general, they sort of get arranged in the ultimate binary in that order. And if you reorder them on the command line, that doesn't have any semantic effect, largely, right, with some exceptions, but it turns out to have a big result on this benchmark, right? So if you just vary these little things, you can get to widely different results, right? And this is an example of a kind of bias called measurement bias, right? So the idea, you perform your experiment in one way, and you reach a particular kind of conclusion, and somebody else who might try to repeat that experiment could not be able to reproduce your results because of some uncontrolled factor that differs between your run of that experiment and the replicator's version of that experiment, right? So there was some feeling, that a lot of the computer scientists were not very good about understanding what the factors were that contributed to the results that we were actually seeing, right? And we weren't really even looking into them, okay, before for artifact evaluation, okay. So this is a paper that was published in 2012. This is from Sigplan Notices, right? So 2012 is pretty early on in sort of the artifact evaluation history, right? And these authors, Jan Vitek and Thomas Calavera, they looked at a survey of different papers in systems conferences, right? And they concluded that people were not very good about producing, their experimental practices were not very good in terms of leading to things that would be repeatable, right? They say, well, important results, they should be repeatable, they should be reproduced, and people should, do experiments that have rigor. And said instead, when you really look into it, a lot of the systems papers they looked at, they said, well, these are unrepeatable results. I can't reproduce this given the data in the paper. Things that nobody has bothered to try to reproduce. And then, of course, measuring the wrong things or measuring the right things poorly. They came up with a list of various deadly sins about sort of scientific claims in papers. It wasn't clear what the goals were, data that couldn't be shared, people who did poor statistics, right? You have the raw data, but then you just report the average and you don't report anything else over the data set, right? There's no baseline for measurements. This is always a fun one, of course, where you say this, my performance, I get 20, my system does 20,000 operations per second. And so, wow, is that better or worse than the existing practice, right? So, and of course, choosing your workload to bias, to make your system look good relative to previous work. And they came up with a list of recommendations, right, including open source benchmarks, codifying best practice documentation, methodologies, and standards, right, and encouraging reproduction studies, right? So we're kind of working our way up to artifact evaluation here, right? And they said, no. So
just wondering if we could turn the volume up just a touch in the front.
Do you want me to?
Oh, sorry.
No, is everything okay? Okay. All right. I will keep going then. Yep. Okay, great. And then, so another reason, of course, that we would be interested in having artifacts around is so that we can actually build on others' work, right? And so this is another favorite paper of mine. This was published at the International Conference on Software Engineering in 2016 on the techniques we create, the tools we build, and their misalignments, a study of CLI. CLI is an abstract interpretation tool. It's not really that important for this talk, what it does, exactly what it does. But in this paper, they say, these authors, they made 6 improvements to CLI that they considered to be software engineering improvements, not research improvements. Okay, so they were fixing bugs in the software, improving the algorithms, or improving the data structures to speed it up or things like that, right? So they made these improvements, and they say, given these improvements, we'll investigate how the results and conclusions of a sample of papers that cite CLI are affected. Right, so a lot of in software engineering circles, it was popular at the time to take CLI, add your particular research feature for analyzing programs, and say, oh yeah, and it works much better now. Okay, so these guys just improved CLI in terms of sort of software engineering practice, and they said, wow, we're going to see how this affects previous work. Okay, so they found a bunch of these papers that previously had built on CLI, and they said that they thought that 27% of those papers, their conclusions might warrant reevaluation in the face of the changes that had been made by these authors, right? So, how did it go? Instead of the 25 papers whose results could be affected, our analysis identified 11 that required deeper examination, right? And it goes on, it says, in spite of our efforts, we were able to replicate the studies in only 2 of these papers. So not so great. They said they were able to replicate one of them, HMP19, that contained a reference to an online repository with all of the necessary code and data, right? What today we would call an artifact, right? The other paper we were eventually able to replicate with the author's assistance, right? IA20, although, they got results that were a little bit different, but that's okay. I mean, a lot of times, for lots of reasons in computer science, we can't replicate performance results exactly. There's a lot of non-determinism in our work, but the idea is that you get kind of the gist of things, right? But this particular pull quote I like a lot, since we didn't receive a response for two of the papers when they were trying to contact the authors of the previous work, and they were for the remainder, we were informed that pending patents work with industrial bodies or unrecoverable code and data prevented them from being able to replicate their experiments, right? So there's this attitude that somehow we were publishing papers, getting the results. You turn your data into a graph, put the graph in a piece of paper, and that's the thing. And then we forget the path that brought us here, right? So we're giving priority to the paper and giving essentially no respect to the process that led up to it or the software that it's describing, right? So clearly a problem in the field, right? Where we're not giving primacy to the things that we're doing, right? We're talking about the papers instead. So that's why also would you want artifacts available? So for producing a survey of work in the field, what in fact is actually going on, right? So this is a paper that was in Computing Surveys. My Zoom window is blocking my notes here. 2016. Okay, and this was so this is StarDroid, right? This is particularly cybersecurity relevant, right? And they said, well, we're interested in analysis tools for Android. Okay, so they went out to survey this work, see what needs to be done in this field, and it says of the 300 security papers that they analyzed, right, only 22 of them published code, right? 6%, 7% published code, right? And worse, they could only get 7 of them to actually run, right? So this is pretty terrible, right? I mean, we're somehow, our research culture is one where, again, we produce these things, piles of paper, and then seem to throw away the primary work that we've done. This leaves us nowhere, no ability to validate anybody's claims, no ability to improve, to survey where we are, no ability to reuse the work of others in order to advance the field, right? So again, this is 2016. So improving the situation. Well, we started doing artifact evaluation. And artifact evaluation, I don't, off the top of my head, I don't know the first thing that was referred to as an artifact evaluation committee that was associated with the conference. But it was, I think, in around the 2011 to 2012 timeframe. I guess I should have looked this up. But the earliest ones that I am aware of sort of started in the programming languages field, right, with conferences like OOPSLA and so on, right? So they came up with this idea of artifact evaluation, right? And what was the point of doing artifact evaluation? Well, again, we have all these problems in our community that were sort of leading up to this, right? But we had sort of three goals in starting artifact evaluation. So the first is just to recognize authors who are creating useful artifacts. We wanted to have some, so people clearly were creating useful artifacts at that time, maybe not everyone, but what was the reward for doing that? Well, of course, your work could be reused and potentially cited and have a bigger impact, right? But it was felt that artifact evaluation would be another way to recognize people by giving people badges on their papers, right? Sort of, getting in life when you're an adult, it's very hard to get A pluses rather than A's, right? And so this is a way to get an A plus, right? So the second, of course, is to improve the papers themselves. So the idea is that we would have some way to people would produce their artifacts, give them to a set of evaluators who then give feedback, and it was possible, right, that the feedback from that process, from the artifact evaluation, could then potentially feed into the paper itself. So if somebody says, well, your paper says that it's 10% faster. And yeah, it seems 10% faster on the benchmarks that you ran, but I ran, I did some minor modifications to those, and it was only, 9% faster, say. Maybe the claims would be modified, right? Or maybe, the idea was to potentially, the process of artifact evaluation would improve the paper's claims, in particular with respect to its specificity, right? And then this third one, I think was also very interesting, is that this was seen as a first step towards repeatability as a review criterion, right? So artifact evaluation is it's not really the endpoint, right? Artifact evaluation was conceived as a lightweight process that could be added sort of on top of our existing processes to sort of get the importance of replication and artifacts, get the foot in the door, right? But the idea was that in the future, at some future time, right, repeatability might be a criterion for accepting or evaluating the papers themselves, right? So I think as everyone in the room probably knows, the standard process of artifact evaluation is that the papers are reviewed, and then some papers are accepted, and the authors of the accepted papers are then invited to submit artifacts, right, to support their work. This was for two reasons. The first was that sort of as a lightweight process, the way to add this on was not to change the notion of paper reviewing itself or change the criteria for paper itself, but have something, now that your paper is in, can you get the star? So it was the point was that the artifact, whether the artifact passed or did not pass, didn't have an impact on whether or not the paper itself was accepted, and that was important. It was seen as important for getting people to adopt this and try this as an experiment. And the second reason, of course, is that if major conferences get hundreds and hundreds of papers, and if all of them came with artifacts that had to be evaluated at the same time, that would increase the reviewer workload quite a lot. And so reviewing artifacts after paper decisions was seen as a way of limiting the extra work that would be involved. Right? So the artifacts get evaluated by a separate artifact evaluation committee, which is typically made of late career PhD students and perhaps early career researchers, both academics and professionals, right? And the original question was, does the artifact meet the expectations set by its paper, which is an interesting question, right? One of the points here is that it's not really a strict criterion. It's the reviewer has to figure out what expectations are actually being set by the paper, and then you say, well, does this artifact support those claims, right? So an interesting thing. And the original artifact evaluation committee, you would get a badge. There was a single badge, and this was the one that was used for PLDI for several years. So as David mentioned in the introduction, I was a co-chair for PLDI 14 and PLDI, a co-chair of the Artifact Evaluation Committee for PLDI 14, PLDI 15. PLDI 14 was the first instance of that conference that had artifact evaluation, right? And when you introduce this into a community, and still it's pretty early in sort of the history of artifact evaluation, 2014 here. So these are the results that we got from that experience, right? So of the 52 papers that were accepted to PLDI 2014, 38% of them participated in artifact evaluation, and only 60% of those passed artifact evaluation, got the one badge. Right? So in some sense, this was sort of a disappointing initial result, but it got our foot in the door. But people were the experiment was successful. People were excited about this. People like getting badges. People will do an amazing amount of work to get a badge, right? So in PLDI 2015, we did much better, right? So the number of papers increased somewhat, but the participation in the artifact evaluation process increased dramatically. Most papers wanted to participate in that, and of those, now the acceptance rate for artifacts went up well too, right? So anyway, this is really taking off, right? So like I said, it became more and more widespread, right? So this was from a conference called Popple, Principles of Programming Languages and Other Programming Languages Conference is sort of the type theory conference, right? Here you might be doing a lot of proofs and things like that, but these are also important kinds of artifacts. And you say, well, it's taking off. People are submitting more and more artifacts, and people are getting better at producing artifacts that can be successfully evaluated as supporting the claims in their paper. Right? Other conferences, people start getting awards, right? Best artifacts, distinguished artifacts. ACM Sigmod had a most reproducible paper award, right? I'm not quite sure how you judge most reproducible, but they had such an award, right? So, and as different communities started sort of inventing this for themselves, and sort of eventually it raises, you go up a level of the organization. And in 2016, ACM came up with their own standard for badging, right? The sort of the result and artifact badging. So this is their article from Communications of the ACM 2016. And this was, the first deliverable from the task force on reproducibility. Right? So ACM is giving, sort of across its many SIGs, right, a standard by which artifacts might be judged, right? It was also felt, of course, that one badge was not enough. If people would do a lot of work for one badge, imagine how much work they would do for 5 badges. I kid. The real problem with one badge is that artifacts can sometimes excel in some areas and not excel in others, and so it was felt that we had to have a sort of a finer grain metric for doing these kinds of things. So ACM came up with a family of 5 badges, starting from the idea of, is it available, right? Are you producing some piece of artifact that's a accompaniment to your paper? To functional, does it seem to run? And does it actually basically, and reusable, right? Is it of high enough quality that it would be something that somebody would really build on? I know several conferences these days that don't award the reusable badge because they feel that the criteria for that badge is too vague, right? So it's really hard to judge whether or not something has risen to the level of reusable or not, right? But the more interesting, probably the one that most people were interested in, is this results reproduced, right? The idea that basically you can use this artifact to produce experimental outcomes that support the claims that are being made in the paper. So either you were able to reproduce exactly the data presented in the paper, or you were able to reproduce data that maybe not quite the same because your computer is faster or slower or has more memory or less memory or whatever, but it's still sort of in keeping with the general claim, right, that your new thing is 10% better or twice as fast or whatever as some baseline, right, in Java, right? So anyway, it's becoming systematized, and organized and widespread. People, artifact evaluation is not at all rare these days. So did we win? A lot of good things are coming out of it, right? So artifacts are used in education. So this appeared in SIGCOMM CCR, the magazine of ACM SIGCOMM in 2017. It's describing a graduate level course that is about teaching computer networking, basically by using artifacts and trying to reproduce results in published papers, right? And so they run a little website. You figure what are the benefits that are claimed in the paper, right? So what did the paper say students get out of this? Well, they get a detailed understanding of networking. These are graduate students, so they dive into the details of the paper to figure out what's really going on. They get graduate students get experience doing experiments. They are encouraged to ask questions about the experiment, sort of the meta questions. Is this experiment done well? Is there an experiment that could have been designed better? Is there some change that should be made, or some extension, some potential for future work here, right? And more generally, just instilling the principle that work should be repeatable, right? We see conferences that have replicability as a criterion, right? So this is from the International Conference on Software Engineering some years ago. It says the research track submissions will be evaluated on various things. Anyway, the point is that replicability might be a criterion for accepting the paper, something that while they might not reproduce the paper, the question is there sufficient information in the paper that would allow me to reproduce the paper if I was going to try? Or reproduction as a requirement, okay, of publications. So as Dave mentioned, I'm the chair of the Artifact Evaluation Board for a journal called the Journal for Systems Research, right, or JSIS, right? And JSIS submissions for certain kinds of papers must be accompanied by the artifact, right? And artifact evaluation happens at the same time as the evaluation of the paper itself. And if we have had cases where the paper gets accepted and the artifact does not, and that prevents acceptance and publication of the paper in the journal, right? And of course, just calls, raising the profile of reproduction studies in the community as a whole, right? There's a high value given to novelty in our community, right? But of course, validating past work, revisiting that, especially in the context of new contexts or things like that. This is all valuable stuff that until more recently was not really being given the respect that it deserves. But science functions when many people are able to reach the same conclusions through independent experiments. Right? So we see conferences now actually calling for reproducibility studies, right? And they clearly report on the results that the authors were able to reproduce, as well as aspects of previous work that they found to be irreproducible, right? So we seem to be winning, right? The papers, they have badges, right? And we are working, but not everything, of course, is finished, and not everything is good. So first question, sort of like, your paper has a badge on it that says that the artifact is reusable, right? And yet I try to reuse it and it doesn't work. So what is this reusable badge, really supposed to be meaning, right? And they say, so this is a publication from the SIGCOMM magazine, again, April 2020. Now they in fairness, they say they evaluated this particular artifact, a data center transport artifact, right, beyond what seems to be the mere criteria of the reusable badge. But ultimately, they say, our our evaluation demonstrates that while it might be reusable, it's still pretty fragile. Okay. So this sort of, leads us into these questions about like, well, what do these badges really mean? Right. It's fairly, some of the simplest badges, they have pretty clear criteria. Right? The artifact available badge says that the software data set has to be on some publicly available repository. It has to be permanently available, which typically rules out like your personal website or maybe even your institution's website. They want it on a Zenodo or something that's really made for archival. Okay. But still, there was this idea that somehow the badges had these funny meanings in different artifact evaluation committees had different criteria for functional. And if you say that the results were reproduced, does that mean that every table in the paper got reproduced? Does it mean that half of them got reproduced? Did it mean, okay. So people are trying to give more specific meanings to these badges, right? So this is a webpage from a conference called EuroSys Systems Conference. And people are trying to provide, these guidelines with things like checklists, right? About, how, in order to get this badge, you have to meet, check, check, check. And to get this badge, you do check, check, check. And in some respects, it's good to have a measure of precision, right? But I have to point out that we don't really have this kind of precision for evaluating the papers themselves, right? There's a lot of judgment that is required. In my experience, a lot of judgment is required in evaluating artifacts on whether or not, again, the central claim about whether or not the artifact supports the claims made in the paper is ultimately a judgment call, right? And so I'm not quite, while checklists give some rigor and structure to the process, it's certainly, I think it is not a replacement for sound judgment. Okay. People still have trouble producing good quality artifacts. It's still a problem for people. Okay. So this paper, did a survey of artifacts that were submitted to conference Uppsala 2019, right? And it says that a lot of these artifacts, they got permission from the submitters to sort of look at the process and report on the process. And they said, a lot of these artifacts, and still even in 2019, a lot of them were not passing the bar, and not just in terms of I'm not getting the right results, but it's just hard to reproduce. It's hard to set up and actually reproduce the tests, right? So we still have issues in all of these categories, right? So tests that run forever, it just takes forever to actually reproduce the results. The documentation is unclear, difficult with dependencies that are not fully captured, or things that work in limited environments, things that were just too complicated, right? So we still have a long way to go in terms of, I think, being able to have a reliable process for being able to produce artifacts that are easily evaluatable, I guess. Now, and of course, I don't think we'll ever get to the point of having sort of push button evaluation, or if we did, it's ultimately not going to be very deep, right? It still takes, we still have there's a big role for judgment here and actual inspection, right? So artifact evaluation and reproduction is still not so easy. We still have a lot of problems with the software environments, things that are incompletely captured. The hardware environments, in some fields, the hardware requirements are very specific. You have to have the latest and greatest hardware. And if you don't have that, well, then you're not going to be able to reproduce these results. How is that hardware going to be made available to people who might want to give you a badge, right? Availability. So even if they are produced, will you be able to find them? And of course, the incentives. Are badges really enough for getting people to continue to do all this work? Anyway, people are doing work in all of these different areas. So people are trying to come up with better practices and tools for producing high quality research artifacts, right? So there's a tool called Popper, right? And this is an article from the Usenix Login magazine. If any of you remember Login, I have fond memories of Login. So they present Popper, a set of practices for organizing software and conducting experiments with the goal of making these things easily reusable, right, by other people, and being able to make things re-execute. This particular tool called Popper builds on work called DevOps, right? The idea of, there's this entire ecosystem of tools for building reproducible configurations of computer systems and maintaining those. And this technique basically is a recipe for using various tools in this way to try and produce sort of automated and high quality experiments. Right? So people are trying to work on better evaluation platforms as well. So this is a paper from some years back about an evaluation environment called Databelle, right? And Databelle it automates many aspects of doing complete and thorough performance evaluation. Oh, there's that echo again. So, anyway, so the idea is that a lot of people only would evaluate their software on a particular platform, a particular architecture with so much memory. And Databelle made a variety of different platforms available. So it gave you different platforms. It would run things with different compiler flags. It would try and mix things up with the different link orders, right? If you remember at the beginning in this talk where we said link order could affect performance things, right? And then it would run multiple trials, and it automates all of this for you, right? So you can sort of think of this as a very fancy build farm, right? With the goal of producing results that were trying to suss out the hidden factors that might be affecting the results that you're seeing that you weren't previously aware of, where it only works with this compiler, or it only works on x86, or so on and so on, right? So these kinds of evaluation platforms, so that we can get more reliable and consistent results. So people are working on platforms for sharing runnable artifacts. So this is documentation from a testbed called Chameleon, right? And Chameleon, you sort of think of it as a cloud for doing research, and they have a particular component of their work called Trovy, and it's a sharing portal that allows you to share research and packaged experiments that are performed on this testbed. Then you can go off and find those and potentially, reproduce those experiments on the Chameleon testbed, right? So this works in terms of resource availability, right? So you can find the artifact, and two, you should be able to reproduce it because Chameleon will give you the resources for reproducing it, right? People are working on different sorts of artifact evaluation indices, right? So these are two websites that have been developed recently, sort of catalogs of artifact evaluation committees from conferences in the systems area and in the security area, right? Now, this is, like I said, this is just a catalog, right? And, catalogs are great, but we would like to have something that's a little bit better. So as Dave has already mentioned before, and I can't fail to mention now, people are working on more sophisticated community hubs for improving the findability and reuse of artifacts. And this is a screenshot of our website for our thing called SEARCCH, right? And so SEARCCH builds and maintains a database of artifacts in the cybersecurity area in particular, right? The idea is it's supposed to lower the barrier to sharing those artifacts and making them more discoverable by people who might want to reuse them. And it will provide features that allow, say, discussion, right? So you say, well, I reused this artifact. This paper reused this artifact. I had trouble reusing this artifact. This one, it continues to work. It doesn't continue to work, right? The idea is to build a community around these different artifacts. So with that, I can wrap up. So artifact evaluation has really changed, I think, the community expectations and practices in the last 10 years in our conferences, right? Artifact evaluation committees are widespread and they just continue to grow and grow. I'm not aware of any conference that, having adopted an artifact evaluation process, decided to not do it anymore, right? I mean, so consistently, people feel that it adds value for all of the reasons that we had talked about, in giving us rigor, encouraging sharing, training students, building on each other's results, surveys of the field, right? And slowly we are moving towards more standard community practices, figuring out what tools we should be using, how to distinguish, reusable artifacts from artifacts that are not so reusable, right? But there's still a lot of issues to be addressed, including the actual discoverability of different artifacts, the longevity of artifacts. So there's still plenty of work to be done.